I want to talk about other ways to measure angles. Up until now, we've only talked about degrees. You might remember from geometry that we have something else called radians. So think about a circle with a radius r that's going to be centered at the origin. So just a normal circle centered at the origin, radius is some value r. Well, a radian is the measure of an angle in that standard position whose terminal side intercepts the arc of length r. What they're saying here is that the radius is along the arc length. So the special value for the radian. Another way to talk about the radian is that it's going to be the value left over when I do circumference divided by the radius. Now, the units of radians are sometimes labeled as radian, or perhaps rad, and sometimes they're not labeled at all. So here's a tip. If you're talking about an angle measure and you see the pi symbol and you haven't had any notification that's going to be in degrees, it means that you are really working in radians. So you might see something like the angle measure is pi, or perhaps pi over 4. That means you're really working in radians. So a full circle, well, we already know that's 360 degrees. In terms of radians, it's 2 pi radians. So if the full circle was 2 pi, half the circle is just 1 pi, which means that we can use the information that 180 degrees is just pi. And we're going to use that when we want to convert from degrees to radians and back and forth. This also means that your calculator will need to be in radians if you're using radians in your question. That, or you're going to have to convert your radians to degrees. Although the scientific calculators I've given you guys links to can work in both. So, if I have to convert between degrees and radians, let's say I'm starting in degrees, all I have to do is multiply by pi radians over 180. If I want to go radians to degrees, multiply by 180 degrees over pi radians. And I'm going to show what this looks like in just a moment. If you prefer using proportions and ratios, you can also do that, and I'll give an example of that as well. For this first one, we're going to look at converting from degrees to radians. Let's go ahead and start out with 120 degrees. So again, I'm going to show it to you two ways. The first way is to say that this is 120 degrees, and let's say I want to get it into radians. Let's call it new value n. So n equals whatever I'm going to find. You can call it x, y, I don't really care. N equals 120 degrees times pi radians over 180 degrees. And again, if you think you might mess this up, don't forget to do 120 over 1. That way you remember that you are going across the top and then down. So these degrees will cancel out. What I'm left with will be in the units of radians. Now this here, that's pi. If that doesn't look pi enough to you, go ahead and you can make that a bit more squiggly. So that's your pi. And I have 120 over 180. So coming through here, I have 120 over 180 pi. And my units are radians, whether I write down rad or not. I want to go ahead and simplify this. Notice that I can divide top and bottom by 60. So if I do that, 120 divided by 60 is 2. 180 divided by 60 is 3. So I have 2 pi over 3. That is the value in radians. So that's one way to do it. I'm going to show you another way also. So I'm going to separate this. Another way of doing this is to say that I have 180 degrees over pi radians. Again, this is pi equals 120 degrees over x. That's the ratio method. Go ahead and cross multiply, butterfly method. I'm going to do 120 and pi, 180 and x. So I have 180x equals 120 pi. And again, when I'm doing this, do not multiply out the pi. I want pi in my final answer. Divide both sides by 180, and I have x equals 120 over 180 pi, and I say, oh wait, that is what I have right here. I already know. What I'm talking about is 2 pi over 3. So from degrees, the 120, I have answers in radians. You can write down the word radian, or you can write down rad, or you can leave it blank. Just know that when I have pi in that final answer, I'm talking about radians. So that's an example going from degrees to radians. Let's take a look at another one. So let me slide this up here. So looking at number 2 here, let's go ahead and do negative 40 degrees. And again, I'm going to show it both ways. Let's have n equal negative 40 degrees over 1 times pi radians over 180 degrees. Degrees will cancel. My answer will be left in radians. So I have negative 40 pi over 180. Notice that I can divide top and bottom by 20. Negative 40 divided by 20 is negative 2. 180 divided by 20 is 9. So I have negative 2 pi over 9. Let's do the same thing using my other method. I have 180 over pi equals negative 40 over x. Cross multiply. 180x equals negative 40 pi. Divide both sides by 180. And like we had last time, this simplifies to negative 2 pi over 9, whether you write the word radian or not. I'm going to go ahead and go through now and box my answers. 2 pi over 3, negative 2 pi over 9. So again, what I've shown there is going from degrees to radians. Now go ahead down here and show an example of radians 2 degrees. So radians to degrees, let's give this as example 3. Alrighty, actually let me color code this in black. There we go. So example 3, I'm going to start with negative pi over 12. So I'm going to say n equals negative pi over 12, and again this whole thing, this is in radians, times, oops, I set up, times 180 degrees over pi radians. So again, radians are in the top here, radians in the bottom there. These pi radians will cancel out. I'm going to end up with negative 180 over 12, and that can simplify. I can divide top and bottom by 2, for example. I'll get negative 90 over 6. They say, oh, I can keep going. I can divide top and bottom by 3. So just keep going this way here. I now have negative 30 over 2. And I go, oh, wait, in the end then, I just had negative 15 degrees. So n equals negative 15 degrees. Let's do the same thing using the ratio method. I have negative pi over 12. Again, this top is my radians. So negative pi over 12 radians equals pi radians over 180 degrees. And as before, we're going to go ahead and cross multiply. So again, I'm using butterfly method. Come along this way, come along that way. Okay, so we have negative 180 pi equals 12 pi. Okay, so in this next one, I had negative pi over 12 radians equals pi radians over an unknown amount of degrees. That's going to be my x. So here, down here, I have x, and here I have x. So x will be my degrees. And then I went and cross multiplied, and that's how I got 12 pi and negative pi x. So from here, my job is to get x by itself. So we're going to go ahead and divide both sides. No. Okay, so for this next one, let's go ahead and label this part here. So for this next version of it, I'm going to take that negative pi over 12, but do it using the ratio method. Now, it might get a little bit confusing, so I'm going to have some notes on the side also. What I'm starting with is negative pi over 12 over some unknown amount, n, in degrees. This is going to equal pi over 180. So again, this is n degrees, that's 180 degrees, these are radians, those are radians. Okay, now notice that I have a fraction over a fraction, which we're actually going to go backwards to teach in a little bit here. So I'm going to show you what I want to do with that off to the side here. I'm going to show it over here. And I'm just going to talk about this part right here. So I'm going to separate that. Think about this as saying negative pi over 12 divided by n over 1. Okay? So negative pi over 12 divided by n, or n over 1. Now, dividing by a fraction is the same thing as multiplying by the reciprocal. So times 1 over n. Notice that let me make this a better pi. There we go. Notice that that n is on the bottom. So I can write that part as negative pi over 12n. That's what I'm going to use. So kind of come back here. That is what I'm going to use in place of this. So I have negative pi over 12n equals pi over 180. Now I'm going to go ahead and cross multiply. Negative 180 pi equals 12 pi n. I'm solving for n, so go ahead and divide both sides by 12 pi. The pi's will cancel, and negative 180 divided by 12, well, from our work here, that's negative 15. So n still equals negative 15 degrees. So again, the ratio method is better sometimes over others. This is one time when ratio looks a little bit more confusing, but it still works as long as you are okay with fractions. Let's go ahead and do another one of that same type. So looking at number 4, I'm still doing radians to degrees. So for this one, let's take a look at 5 pi over 4. And again, I'm going to show it both ways. I'm going to show it using the decimal multiplication method as well as the ratio method. So let's say I'm going to use the multiplication method. I'm going to have n equals 5 pi over 4, and again, that whole thing is radians, times 180 degrees over pi radians. Okay, so what I've got here, my pi's will cancel. N equals 5 times 180 over 4. That whole thing will be in degrees. Well, notice I can do 180 divided by 4. So, again, come back to here. 180 divided by 4, that gets me 45. So this part here is 45. So n equals 5 times 45, 225 degrees. So n is 225 degrees. That was the multiplication method. So again, here I said 180 divided by 4 to get myself to 45. I then multiply by 5 to get to the 225. Go ahead and separate that here. Let's go ahead and do the ratio method. And like the last one, it's going to be one of those fractions within a fractions. So I'm going to start with 5 pi over 4 over n equals pi radians over 180 degrees. And yeah, technically n is in degrees as well. And again, off to the side here, I'll show my little scratch board work. I'm thinking of this as saying 5 pi over 4 divided by n. Remember, dividing by n is the same thing as n over 1. And dividing by a fraction is the same thing as multiplying by the reciprocal, 1 over n. Meaning what I have is 5 pi over 4n. That is what I'm going to use. So I have 5 pi over 4n equals pi over 180. Go ahead and cross multiply. So I'm going to have 4 pi n equals 5 times 180, 5 times 180, pi, that is a pi symbol. Go ahead and divide both sides by 4 pi. Notice at no point in time am I actually multiplying the pi out. Pi will either stay in my answer if I'm converting from degrees to radians, or pi will be gone because it cancels out entirely. So again, the 4 pi's are gone over here. I have n equals. These pi's are gone over here. I have 5 times 180 divided by 4, and I go, oh wait, that's what I did over here. Therefore, n is just 225 degrees. No matter how you spin it, that's the same answer that you are going to get. So, in this section here, we've covered how to convert from degrees to radians and radians to degrees.